Now that we know what ratios and proportions are, we can use those in similar polygons. So we're going to look at proportions to identify similar polygons, and then we'll do some basic problem solving for similar polygons as well. First off, what are similar polygons? We're going to say that similar polygons have the same shape, but not necessarily the same size. Remember, we talked about what congruence was. Congruence and congruent polygons were polygons that had the same shape and the same size. Now we're saying we're dealing with similar, where they will have the same shape, but not the same size. So down here, we would consider these two polygons to be similar. We know that they're similar for a couple reasons. One, each angle in this polygon is congruent to an angle over here. So angle A is congruent to angle W, angle B is congruent to angle X, angle C congruent to angle Y, and angle D is congruent to angle Z. We know that all the angles have a congruent angle in another polygon. We also know that these polygons are similar because their corresponding sides are going to reduce to the same ratio. So for example, if I would put 18 over 6, 15 over 5, 12 over 4, and 21 over 7, each one of those side lengths is going to reduce down to 3 over 1, or just 3. Just like how we had congruent statements, we have similarity statements in the fact that all of your corresponding angles and sides are going to match up. But the similarity statement symbol is just going to use the little squiggle. I don't know what it's actually called on the keyboard, but that's the symbol that we're going to use for similarity. So in example 1, they just want us to match up the congruent angles and then write the proportions that relate the corresponding sides. They'll give you a picture, but again, the picture can kind of be misleading. I would mostly use this similarity statement up here at the top. So I'm first going to start with the angles. Since angle A is in the first position and angle R is in the first spot, they're going to be congruent. So angle A is congruent to angle R. Angle B, we would say, is congruent to angle S. And angle C would be congruent to angle T. So there are our congruent angles. Next, we'll do the side lengths. I don't care which triangle you put on top of the other, just as long as you're consistent. AB would go with RS. Notice how AB is in the first two spots, RS is in the first two spots. That should equal BC over ST. And then finally, CA, which would go with TR. If I was to reduce each one of those side lengths, they would reduce to the same thing.